Hello, everybody. So sorry for the delay. There were some technical issues, I think. Hopefully you can all hear me. And welcome to my talk on refactoring legacy code with Kotlin. My name is Ash Davies. I am a Google developer expert for Android, and I'm working for mdevcamp in Berlin. So this talk's going to be on idiomatic usage of Kotlin, about how you can take advantage of these features when you're looking at older, maybe Java code, and how you can improve the quality of your code base and make it more testable, and improve in these aspects. So let's sort of reflect on what legacy code is. So the definition of legacy code is, of course, software related to software or hardware that has been superseded, but it is difficult to replace because of its wide use. So this actually reminds me of a definition from the book on working effectively with legacy code from Michael Feathers, where he defines legacy code as code without tests. Now, this is a really interesting definition because it's a reflection of how confident you can be in your code base, and how reliably you can refactor legacy or older code. So if you don't have any tests on your code, then you can't be certain, or you can't be sure that the changes or refactorings that you're making are actually not causing regressions. So it's really difficult to manage that. But I prefer to sort of take a bit of a more subjective approach, and that is I consider anything that is Java to be legacy code. But focusing mostly on untested codes, we want to get regression tests in here, and we want to, improve this confidence we have in our code base so that we can, do so more with confidence and with ease and reliability. So let's sort of take a look at our environment. We are working in a Java world, or at least in the JVM world, and though Android is sort of built upon Java and JVM, Java is kind of out of our reach, and that's kind of because the Java virtual machine is not the same as the Android runtime. The reason for this is because, of course, you can't have a full-blown Java environment on a very small device. So Google had to optimize the hell out of this runtime so that it was able to work on lower spec devices. Of course, these devices are now more and more powerful these days, but this still rings true. That these two things are not the same. So every time Oracle or Sun had created a new version of Java, we would have to then wait for the APIs to be ported over to the Android runtime. This has actually led to a bit of a dispute about what you can call an API and how it can be copyrighted. I'd like to draw your attention to this hilarious tweet, which I find personally really funny. Anyway, so Java 8 was obviously released in March 18th, 2014, which was a long time ago, and gave us the introduction of Lambda expressions, method references, default interfaces, things like try with resources, and most enjoyably, streams. Now, these are often Java 8 features that are only available with the Android Gradle plugin version 3.0, and you have to target things with min SDK 24 or higher. Now, for a lot of people, 24 or higher is fine, but some of us still have to do 21 or earlier versions. So we are left in the dark. We can't use these lovely features because Java. So, of course, a few years ago, Kotlin came in, and it was announced at Google I/O 2018 that there would be first-class support for Kotlin as an Android developer language. And then later, Kotlin was announced as the preferred language in 2019. So this is a fantastic step forward because it means that Kotlin is actually almost shipped with your code. So you benefit from the same code and programming features as any other version. So there's lots of reasons to love Kotlin, but let's go over a few, just in case you need persuading. You have consistently familiar code. It looks the same to everyone. It's recognizable. It has low cognitive load. You can understand what it's doing. It behaves idiomatically. These are idiomatic features. I'll go into more about what idiomatic features mean in Kotlin, but it, as a result, makes it much easier to understand the behavior of the code. It looks terse and concise, so you don't have a lot of boilerplate or unnecessary code there. And the aggressive development from the JetBrains team is really quite refreshing, that we get all these nice language features and all these nice introductions, things like inline classes, coroutines, and all these kind of nice things. We don't have to wait for the Google team to implement this in the Android Gradle plugin. I'm using hacks like desugaring. It's first-class support as part of the language, which makes it much more enjoyable and much more reliable to use. One of the biggest features, of course, of Kotlin is its nullable awareness. Now, many of you probably already know about nullability if you've programmed anything. And you might know that it's often referred to as the billion-dollar mistake. Now, the reason why it's called the billion-dollar mistake is because of a quote from Tony Hua, who said that this has led to innumerable errors, vulnerabilities, and system crashes, which has probably caused billions of dollars of pain in the last 40 years. So this man is the person who invented the nullable reference and later came to regret it. But what does a null reference look like? Oh, sorry, what does a null check look like? Well, it's quite simple. It's just a simple guard where you execute some behavior inside a conditional statement. Now, you can consider this to be called defensive code. Null checking is defensive because it sort of guards its input and behaves differently if there is a failure of validation. Now, a lot of people advocate for this for the reason that it means that your app is less likely to crash. And of course, we don't want our users to see crashes. But unfortunately, it actually makes your code and your application polymorphic, which means that it will behave differently in different circumstances on different execution paths, which means it's harder to optimize for the JVM. And you can't easily predict why things might be going wrong. So your user might be seeing an incorrect view state, but it's hard for you to actually reproduce this because we don't know the actual cause of it. The cause of it might have happened 10 steps before, but we didn't know because it was defensive and guarded against the input. Maybe returned an empty string instead of a null, or just didn't execute some view behavior because something was null and it should have crashed. So if you compare this to the inverse of defensive code, you can refer to offensive code. Now, offensive code has a very low tolerance for errors, and it just doesn't tolerate them, basically. If you've ever worked with RxJava, you're probably familiar with the confusing stack trace that you sometimes get, and you can't really find out where the exception was thrown because it kind of catches the original exception and throws it in a new place. So it's actually harder to kind of find out what's going on. So the earlier in your process that you throw an exception, or you do not tolerate failure, then the more predictable and the more easy it is to find this error because you are looking for the error at the actual location of the invalid input. Another really nice aspect that I like about offensive code is the sense of urgency that it lends. Now, consider the scenario where you're working in a company and you have a product owner and you're working on a feature. Now, if something is a non-fatal crash, which means it's just logging and it just has an invalid user state, then this is going to be treated with a much a lower priority than something that is actually causing the crash. Now, one could argue that it should never happen in the first place, but the more times you correct these errors and the more times you kind of fix the errors in the first place because they were throwing as early as possible, you tend to find these in the development process. So most of these crashes will actually be filtered out and resolved before you even get to your users. But in the edge case where something does happen, you fix it very quickly. This is an approach I use with a lot of my projects. I think we currently have a crash rate of 99.89, I think. Sorry, a crash-free rate of 99.89. So if you have the resources and you have a large enough team, then I would definitely recommend doing so. So back to idiomacy. Why do these kind of relate to idiomatic features of Kotlin? Why is nullability and defensive and offensive code relevant here? Well, let's look at the definition of idiomatic, an adjective containing or denoting expressions that are natural to a native speaker. Now, in this context, it's important to remember that native speaker means the native language, programming language you're using, not the native verbal language like English or German or Czech. This is referring to consistent design patterns and consistent expressions that are relevant in Kotlin and are ubiquitous in Kotlin, so then therefore become recognizable and easy to understand. You can check out the documentation on the coding conventions and idiomatic uses of language features to find out more information. But I'm going to go over a few of these and kind of give some context as to why they can be used with legacy code. So, of course, idiomatic use of language features is less ambiguity. It means you have an easier learning curve for new contributors. Maybe if you've got somebody new on your team, or if you are changing your team at all. And it means you're spending less time when you're reviewing code over the style of the code, and it's much more quicker, and you can be more productive. So you have consistent, easy to read code. As I mentioned, less cognitive load with less ambiguity and a preference for function over style, which is quite nice. If you've worked with other languages which have very opinionated formatters, such as Dart and I think Go, please somebody correct me if I'm wrong on that one. They kind of have a very opinionated formatter that forces you to have this format whether you like it or not, meaning that you don't have to worry about having the right semicolon here or the right parenthesis here. It's all about the actual behavior of the code. And when the style and everything looks exactly the same, it's much, much easier to understand. So you can actually go and check out the Kotlin style guide recommendations from Android as well. I recommend using these as a source of truth, and also then the recommendations on Kotlin code style from JetBrains. These two are complementative. They don't conflict with each other, so you can use one and or the other. Furthermore, you can use KT-lint, which is an anti-backshedding Kotlin linter. There's also a KT format from Facebook available. I've not yet used that myself, so I would be quite happy to hear from any of you who have used this and your experience with it. So back to the actual topic we were all wanting to hear about, refactoring legacy code. How can I start converting my Java code to Kotlin? Well, you might know this shortcut. It's a shortcut in IntelliJ to automatically convert a Java file to Kotlin file. Well, you might think job done, right? Surely JetBrains and IntelliJ know the best things for my code and they will do it automatically. Well, not quite. It can be a good point. This could be a good learning resource if you are new to the language or you want to try something out. But I definitely wouldn't only use this. Maybe use it to start off with and then correct it afterwards. But it will then make a lot of assumptions about your code, which are often incorrect because they have to be quite conservative with their tooling. So an example of this is referring to nullability, because you're going to have to handle nullability different in a lot of different cases. And you can't easily predict if you're an IDE tool, what that use case should be. So consider this copy maker from a well-known piece of documentation for a well-known dependency injection framework that we all love. So this is, of course, a bit of a Java code where we have two injections. We are using field injection here rather than constructor injection. This is intentional, and I'll go into that in a second. So the immediate conversion using this command, Shift, Alt, and K, will give you something like this, because it has to make some assumptions about what this thing is, because there were no annotations on the field, so it doesn't know whether it should be null or not. So it has to make the conservative guess about it being null. It also has to make sure that it's a variable property that can be set, so it's not immutable, and it means that you have to then use the double bang operator every time you want to access any one of these references, which can be a bit tedious. You also don't make use of any visibility functions in Kotlin. So let's take one step to sort of improve this a little bit and make use of two idiomatic Kotlin features, and that is the internal visibility operator and the late init operator. Now, late init was sort of built with Android in mind, that it allows you to sort of set these properties after the fact. So they may actually still be null, but they're not represented as nullable types. So it's sort of like a hack in some sort of ways. So if you try to access this one of these properties before they're actually initialized, it will throw an uninitialized property exception. You can also use a double bang operator to then throw a different type of exception because maybe you prefer this. Or you can then check if the field is initialized and then execute the behavior conditionally. But you might remember this is quite similar to our null check from earlier, where we're checking something's existence and then acting accordingly. So here we have defensive code, and we're not actually doing anything if it's not initialized yet. So this could end up with race conditions where you are expecting some initialization to happen on class instantiation, but things haven't injected yet. So you're going to have things executing in the wrong time, and you're going to have a compromised user experience. So let's keep it simple and actually just go with the actual direct access. We're using late init for a reason, because we're confident that we are actually initializing it. So we can safely then assume, this is not null, and we want to throw it if it is actually null in here. So this will throw, as I mentioned, an uninitialized property exception. You can improve upon this actually as well. And you might have seen some of the functions in the Android framework source code that have started using this require keyword in methods. Things like require context, require parent fragment, require view, or these things sort of provide a little bit of context as well as to why something isn't there. So in the example of require view, it'll throw an exception saying the view is not attached. So that gives you a bit more information about what actually went wrong. You can see without having to investigate straight away. That might look like this. You can use the require not null method in Kotlin to verify that something is indeed not null. You'll notice as well that I've removed the injection here just to compare this with a nullable property. And here you can say this property was null because of XYZ, and then it will return you the non-null type. It's much more informative and much earlier feedback that we can tell what went wrong. You can go one step further and actually start creating your own exceptions. So you could create a custom exception that has additional context and data about what went wrong and why, that you can then handle further logging with. And then use the Elvis operator to coalesce the potential null value. And when I was writing these slides and I created this impossible exception, I was reminded of a comment from XKCD, which I'll share with you now, that you basically shouldn't write an exception message when you're tired, because we as developers, we tend to be extremely conservative at times. And even if we think that a position should never, ever be reached, we would still guard against it, or still throw an exception, or still do something. So these messages are often quite hilarious. And you could also argue that they are a nice little Easter egg for your user. Another really nice idiomatic Kotlin feature is coming from the use of beans, or Java beans. Not the coffee beans or the granules, the very verbose classes that have properties. These are simple POJO objects, which is plain old Java objects. And they represent almost any sort of data model in the Java world, where you might have immutable properties. You might have mutable properties, and you'll usually have a constructor, and you'll have a handwritten or IDE-generated equals and hash code implementation. So what happens if you apply the automatic code generation to this file? Well, we get something like this. Now, the first things to kind of make note of here is that we still have this equals and hash code implementation. So why is that? That's because the IDE, or at least the Kotlin toolchain, cannot make assumptions about the validity of your implementations. So say, for example, if your implementation acts a little bit differently in a certain circumstance, that's going to be hard to predict for the tool. So it has to actually leave your original implementation, even if it was actually wrong in the first place. It's not the place for the tool to correct you. Might also notice here that we have nullable properties and we have mutable properties. Anyone who started using Kotlin might be able to suggest that we use a data class here, which is a great suggestion. So we have this nice little data class now, which has a mutable property and a non-null property. We can then use things like a copy function to then mutate it into a new instance of a class. And this forces us to create immutable objects. Immutable objects then usually lead to a correct immutable unidirectional data flow, which is really much easier to understand where and what is going and why. You can see the flow of information through your application, and you can debug and detect issues much easier. much more easily, sorry. Another nice idiomatic feature is extensions. Now, we might be familiar with this from other languages. I can't remember which other languages actually have extensions, but there are some. And you can take the example used with the core KTX library. This is the shared preferences object that you might be familiar with, where you edit it, you put a property, and then you apply to the transaction. Now, if you define the extension function .edit on this, which is what we'll find from the Android core KTX library, where it has a bit of code which can then be inlined into your core site. The interesting thing as well about this is that it's using the inline keyword here at the very beginning, and that means that in the resulting JVM code, the contents of this method will pretty much be sort of copied to the call site. So you don't really have any performance impact of using this function. Only really works for functions with lambdas. You probably shouldn't use it otherwise. And it means we can take what we had here, the shared preferences.edit, and turn it into something a bit nicer, a bit more consistent or idiomatic of Kotlin code, and that is of using a nice little lambda here. So Kotlin style has always been about defining a domain language, a DSL as such. And this is a hot word thrown around by a lot of people, and really it's not actually that complicated. A DSL isn't necessarily a strict feature at all. It's just something you do with the features that you have available to you. And DSL in Kotlin makes heavy use of lambdas and nested lambda operations. So you can start building a language that is more consistent with your domain, with your company, with your project, and you can use these features as such, which makes it more idiomatic and concise. As I mentioned, the documentation is at the Kotlin Lang website, and you can check out all the idioms there. Other things like default values and parameters, singleton objects, string interpolation. This is one of the most lauded features I've heard of from Java developers about being able to include variables and simple expressions in your strings to interpolate them. You can make use of destructuring syntax. This is probably more familiar to JavaScript developers, where you can take an object where if the the class instance is a data class and has these component methods generated for it, you can destructure these into individual variables. Consider maybe a pair of two values, like literally pair string, and you want to turn it into two strings. You can do so with destructuring. Scope functions, which can sometimes be misused. You have run, let's, also, and apply based upon the type of receiver that you want, based upon the type of parameter you want. There are lots of nice resources online to give you hints about which ones to use and where. I won't cover that. It's not relevant for this talk, but I can share it later if anybody is interested. So a lot of questions I get about Kotlin or migrating to Kotlin is how to maintain the history, because you're effectively changing a lot of things in this file. So wouldn't the Git history or the Git blame be overwritten? And yeah, unfortunately, that is true. That's going to happen. And in some cases, if the file changes dramatically, there will be no link or no logical link from the old file to the new file, which means you've lost all that very important history that was with this legacy class, because you might have hacks that have been implemented over the years that give you a bit of context as to the state of your application or the state of your APIs or your backend or your system. But anyway, if you overwrite this, then you lose a lot of that history, and you don't want to do that. You want to keep this because it's going to be useful for you in the future. So there is a mechanism in which you can do this with the auto migration tool, where you would change the file name to .kt, commit that, and then convert it afterwards. So then it would have the same reference to the file. This sort of works if you don't use Git squashing and if you have a timeline of these activities in your main master branch. But I'm not going to show you how to do that because I think there is a better way of doing it. And that's what I'd like to share with you. And that's through refactoring, clues in this talk title. But I think refactoring legacy code and migrating to Kotlin with this gives us a unique opportunity to then come and address some technical debt that was already there. And you can then use this opportunity to improve and update your code base and make it more reliable and more offensive coding, that is. Aha. So obviously, when refactoring, you sort of have to always keep in mind the solid design principles. Now, solid design principles is an acronym for 5 sets of principles. These they've become a bit of a cliche, I will admit, but I think these lessons are still relevant today. Just treat it with a grain of salt, I guess. So you have the single responsibility principle, the open-close principle, Liskov substitution principle, because apparently we needed an L in the middle to make solid, interface segregation principle, and dependency inversion principle. Now, the first thing that comes to my mind when I look at all these different principles is that somebody really wanted it to spell out solid. But the main thing you can take away from this is basically single responsibility. I believe that each one of these 5 just is an extension of single responsibility. Make sure that your classes are simple. They're not doing too much. They don't only have one responsibility or one kind of purpose. Now, where you define what that purpose or how broad is up to you. But generally, as you see a class grow, you can get a bit better at learning to identify potential abstractions and improvements that you can make by move things away from that class. So things like extracting logic into a new class that is untestable on its own instead of having it inside this massive God object. And as always, of course, depend on abstractions, not concretions. And always remember that Uncle Bob is watching you. So solving these problems, I think, gives us a better understanding of the requirements of the code as well. So in the same way that we would perform repetitive code dojo or kata exercises to hone our skills as developers, to become better and improve and find alternative solutions to similar problems, this allows us to do the similar thing. So we actually then go revisit an old problem and then think, okay, so did we actually use this best solution here? Can I think of a new solution with the tools that we now have available to us? So this allows us to get a sort of fresh perspective of the actual problem going on. And when you can compare that to the previous implementation that you might have written, you can often find that you'll find a different implementation or some slight improvements. You have a better understanding about what's going on. Maybe you didn't actually write the code in the first place, and you need to have a better understanding of what's actually going on, so you can then safely refactor. You can then write some tests. You can then have a bit of knowledge. You want to make sure that you share this knowledge in your team so that it's not all in one individual silo or one person. Another thing is, I think that these principles sort of discourage the use of static, and so does Kotlin in this way. So of course, the static keyword just doesn't exist in Kotlin, but you can achieve it in similar fashions with companion objects and top-level variables. But generally, I feel that Kotlin encourages you into more object-oriented design patterns, and object-oriented design, obviously. Is someone speaking? So object-oriented design is much nicer and much more easy to test since it's much easier to inject our dependencies. And then further, we can use concurrency. Now, concurrency is a very fun topic and obviously deserves a talk on its own, but I'll try and cover it as best I can here. So concurrency, what is concurrency? Well, concurrency is sort of asynchronicity and when you want to handle tasks in parallel. You shouldn't confuse concurrency with parallelism. These are slightly different things, but they operate in the same idea. In Java, what might a simple background operation look like? So we want to perform something asynchronously. We create a new thread and call foo and start. So this is the most simplest way of doing it. It's not very efficient. It doesn't scale very well, and it's not encapsulated or cancelable, so it has some issues. Next, we have other types from Java World, Java 8, where you have a completable future, where you can then use this sort of chain syntax of sequential operations, which is a big improvement. And then if you compare this to what we're more familiar with Android, with RxJava, you might have a very long observable chain with different operations. One example I'd like to share with you is this piece of very embarrassing code, which it's difficult to read. I definitely didn't get this from my own code base, and it definitely wasn't written by me. But it's really hard looking at this to understand what it's actually doing, where the actual operations are going on, because there's a lot of conversions going on here that are kind of very specific to RxJava. Things like zip with or default if empty, these things like maybe and single and observable. They require a lot more verbosity to manipulate. So you're doing a lot of different conversions here where you're only probably making one or two actual important calls. And it forces you to use what are called Pokemon exceptions, because you've got to catch them all. It catches everything, and you don't get to specify what type of exceptions you actually do want to catch. Because sometimes you expect certain exceptions, and one exception can be an absolute catastrophic error that you want to kill everything so that you can fix it. Now compare this to what we have in Kotlin, and we have coroutines. Now coroutines allow for, coroutines are subroutines for non-preemptive cooperative task managing. They execute sequentially with a sort of seemingly imperative syntax. And it looks like synchronous code when you're reading it, and it uses the DSL sort of nested syntax that the Kotlin affords. So consider this example. This is from the documentation on Kotlin website. It will simply print hello world after 2 seconds. Now, the first bit of code looks like it's before, but obviously because we are delaying by 1,000 milliseconds, it will happen after the invocation of print hello. And then afterwards, of course, we want to sleep, so we make sure that we can see the output. So this is not necessarily required. Here we're using the global scope. This is sort of a representation of your application, the whole process. You wouldn't want to do this normally in Android. You would want to make sure you define your own scope. You maybe use lifecycle scope or view model scope. And then you can manage the teardown of that scope, making sure that any coroutines that are still running will be terminated. And don't forget that coroutines are require cooperative cancellation. So that means that you have to check if you should be cancelled or not. If you're using suspended functions from the Kotlin framework, you don't have to worry too much about this, as these all do that for you. So one of the really nice things as well about Kotlin Coroutines is that it has all the nice things about Kotlin. It's a native first-class library. It's a first-class support from both JetBrains and Google, and part of the actual Kotlin Kotlin trust, let's say, where we can be sure that we're not going to have a similar situation where a mega corporation purchases the IP and then tries to sue Google. So that's why we have the Kotlin Foundation. Which means that we're getting like real-time updates. If you ever have an issue with Kotlin, if you've ever had to file a bug, the Kotlin team will actually very, very, very quickly address this. And you'll get a response very quickly. Maybe sometimes it's I won't fix because for whatever reason, but the team work incredibly diligently on this, and it's really nice. It's incredibly efficient overall. Coroutines you can run several 100,000 threads and performing an operation where normal threading operations would just simply overflow. It's really easy to use. If you're not so familiar with it, you can simply just have a suspended function and then use it in a scope where you have higher up the chain. So just suspend everywhere and then consume in your scope. So coming back to our example, let's say we have to refactor this. We have some blocking code, or we have some synchronous code calling from some legacy operations, and we want to move this to a new function so we can test that function in isolation and not have to worry about how the rest of the system operates. So it's actually really quite simple. You can just call just move this to a new function and suspend it. So everything inside this function, you don't have to call anything from your scope. You don't have to worry about having scope. You don't have to worry about dispatching. Well, you maybe do need to worry about dispatching if it's relevant for you. But if you're using libraries like Retrofit or Room, the scheduling will be handled on these libraries for you, and in a lot of other libraries as well. But if you do need to use dispatchers, you can then just say with context. Always use with context instead of launch, as you do not want, as it's more expensive and it's simpler to do it like this. You'd also probably want to inject your dispatcher here so you can test it a bit easier, but here I'm just showing it for brevity. And then furthermore, suspended functions. Suspended functions are really 3 minutes. Furthermore, suspended functions are really easy to test. You can use the Kotlin Coroutines testing library and then use this run blocking test function. Now, the really nice thing about this is that it will then create a test dispatcher in the background for you to use, and then makes sure that any delayed operations, like say, for example, you have a sleep or delay, no, the delay not sleep, sorry, in your suspended function, this will automatically advance the internal clock so that you don't have to sleep in your tests, because sleeping in your test is not great. And it will also make sure that there are no coroutines still running once the test tears down. So maybe you left an ongoing operation going and you didn't cancel it, so you can then verify your test, your cancellation behavior by default. It's given to you for free, which is great. This library you can find here with this artifact ID. I think they're not on 1.3.3 anymore, but you should still be able to find the latest version. And the documentation is available on the website that I linked earlier. So that's all from me. Thank you very much.
Thank you, Ash.
Shall I check Slido? Let's see the questions. I only see one question. That is, how much percentage of lines of code have you removed when refactoring big projects to Kotlin? I think it's hard to measure sort of a line of code since like the project that I'm working with is quite big. I couldn't actually tell you how many lines of code we have on the top of our head, but the project is easily about 15 years old. Not 15 years old. Android's not even that old. About 10 years old. And we started developing it in the very early days of Android. So in our project, we've been using Kotlin for about nearly 3 years. And my last check was, I think we were at about 55 to 60% Kotlin. We still have a lot of Java code because I would encourage you not to just blindly migrate Java code because of wanting to go to Kotlin. Find a purpose for it, find a reason. Improving the quality of the code, improving testability, just abstracting it to use idiomatic Kotlin features. Don't convert your code base to Kotlin just so you can have a percentage of Kotlin code. But in reference to the original question, I'm not sure I can answer that. I don't have the numbers for you, but yeah, we're about 65%, 55% at the moment.
55? That's cool.
Around about. And I can actually probably check live.
In my project, we saved 25% by migrating. Yeah.
Oh no, I'm actually quite wrong. So actually, we're on 70%. 70% Kotlin, 28.5% Java, and 0.8% other.
Cool. So thank you, Ash. Ash is now going to a 3D world, and he will be in a speaker's corner next to the stage. You can find the desert stage because it looks like a desert. It's all yellow and sandy. So next to the stage, there is a circle. Ash will be there during this break. You can ask him even more questions. And when you are in the 3D world, also check out our partners booth. There are some surprises for you. I think you can unlock some unique avatars or flying or even win some prizes at the partner booth. And now in Slido, I will enable rating. So you can now rate Ash's talk. Please do. So thanks, and we will meet again here at 1500 for the next talk. Thank you, Ash. Bye.
Thank you all.